Today, one of the most mature tools for configuration management is Puppet. But I know most of you must be wondering, why is it so popular and what makes it unique? More importantly, why should you learn how to use Puppet for your individual and organizational needs when there are many other contemporary CM tools in the market? Hi all, I welcome you to this Puppet tutorial by Edureka, and today we shall discuss the answers to all of the questions that you might have. But before we begin, let's look at our agenda for today. First of all, we're going to start out by introducing you to the concept of configuration management. Here, we're going to talk about what is configuration management, why do you need configuration management, and all of this using a case study. Next, we are going to discuss what is Puppet, followed by why do you need Puppet, as in the advantages of Puppets over its competitors. Then we're going to move on to our demonstration where we shall learn how to install and set up machines, the Puppet master and agents, sign in certificates, before we finally summarize the session. Also, do kindly take up this time to subscribe to us and don't forget to hit that bell icon to never miss an update from the Edureka YouTube channel. Also, to learn about Puppets, Jenkins, Docker, Ansible, and more such DevOps tools, do not forget to check out our training program, the link to which is given in the description box below. So without much ado, let's get started. So what is configuration management? Why do you need configuration management? Now, system administrators usually perform repetitive tasks such as installing servers, configuring those servers, so on and so forth. They can automate this task by writing scripts, but it is a very hectic job when you are working on a very large infrastructure. So meet our team. We have Dave, the developer, Sam, the sysadmin, and Alice, the manager. How the workflow goes is Dave passes updates to the operations team, which is Sam. So when Dave is done with a certain software update, he pings Sam to deploy it on the servers. But Sam then has to deploy the update on each and every individual server, and it's going to take him a significant amount of time just to deploy this new update to servers. Meanwhile, the manager Alice comes in with great news. They've been getting traffic on all of their servers, and she wants Sam to add 200 more servers to their system. But Sam hasn't even updated the current 20 servers with Dave's changes. How is he going to do that for 200 more servers? Now, there are a couple of issues here that Sam is facing. A few major ones are having to configure a large number of servers together, scaling to new servers manually without any configuration management tool, and the fact that there is always a development and deployment environment mismatch, which is going to halt his work from time to time. Now, to solve this problem, configuration management was introduced to workplaces. Configuration management is the practice of handling changes systematically so that a system maintains its integrity over time. Configuration management, or CM, ensures that the current design and build state of the system is known, good, and trusted, and doesn't rely on tacit knowledge of development teams. It allows access to an accurate historical record of system state for project management and audit purposes. So with configuration management, you overcome the following challenges. You figure out which components to change and when the requirement changes. You also redo an implementation because the requirements have changed since the last implementation. You can also revert to a previous version of the component if you have replaced it with new but flawed versions. And finally, you can replace the wrong component just in case you couldn't accurately determine which components needed replacing. So now, in an automated scenario, Dave passes updates to Sam, and scaling up is no longer an issue. And adding 200 more servers, as said by the manager, is not really a problem with the help of configuration management. Sam can easily scale, deploy, and configure as many servers as his manager wants. The best example for this that I know is that of the New York Stock Exchange. A software glitch had prevented the NYSE from trading stocks for almost an hour and a half, that is 90 minutes. This led to millions of dollars of loss. A new software installation was actually the cause of this problem. The software was installed on 8 of NYSE's 20 trading terminals. However, despite being tested out the night before, it failed to operate in the morning properly on its 8 terminals. So there was a need to switch back to the old software. As a result of proper configuration management, NYSE recovered from that situation in 90 minutes, which is pretty fast for a scenario like this. Had the problem continued longer, the consequence would have been far more severe. Now, I hope you understand the importance of configuration management, which is considered the backbone of DevOps. It allows more frequent software releases in the safest and most reliable way possible. Configuration management is all about bringing in consistency in the infrastructure. It is done by ensuring that the current design system, state, and environment is known, trusted, and agreed upon by everyone. It also helps record all the changes made in the system. Configuration management tools provide an easy approach to manage and configure servers. It enables users to manage and configure the entire infrastructure and its environment. It makes writing individual scripts for servers time and time again just to get little things done obsolete. And it does so by one concept in particular: infrastructure as code. Now, here is a shell script and a configuration management tool script that you see in front of you. Both are adding a user to a host. But while the CM tool script is easy to understand and write, as you can see, it's almost pure English, the shell script is harder to understand, and you'll have to learn to write shell scripts of your own in the first place. Now, infrastructure as code enables the automation of IT operations, which is to build, deploy, and manage by provisioning of code rather than manually handling each phase of different environments. Basically, what it does is that it bridges the environment differences sysadmins have encountered every time they had either tried to deploy new code or set up new servers. And it obviously has its own advantages. For example, provisioning servers using infrastructure as code is way easier than writing shell scripts. Shell scripts will require workflow definitions, as you just saw, whereas the CM tool scripts have predefined workflows. So that basically makes the CM tool script easy to understand and write, while eliminating the requirement for learning how to write shell scripts separately. Now, there are a few very popular configuration management tools such as SaltStack, Ansible, CF Engine, and Chef. But the one that we want to talk about today is Puppet. Now, Puppet is a configuration management tool that helps orchestrate, provision, deploy, and configure the entire infrastructure of an organization. It enables users to concentrate more on making delivery faster and more reliable rather than continually fixing mistakes. It defines distinct configurations for each and every host and continuously checks and confirms whether the required configuration is in place and is not altered. And if altered, Puppet immediately reverts back to the required configuration on the host. It also helps in dynamic scaling up and scaling down of machines while providing control over all of your configured machine. So a centralized or a master server or repo-based change gets propagated to all automatically. So Puppet uses a master-slave architecture. The diagram in front of you depicts what basically happens. So let me break it down for you a little bit. There's something known as a Puppet agent which sends facts to the Puppet master. The facts are basically your key value data pair that represent some aspect of the slave state, like its IP address, its uptime, operating systems, or whether it's a virtual machine or not. The Puppet master uses these facts to compile a catalog that defines how the slave should be configured. The catalog is a document that describes the desired state for each source that the Puppet master manages on a slave. And finally, the Puppet slave reports back to the master, indicating that the configuration is complete, which is visible in the Puppet dashboard. The Puppet master and slave communicate with each other through a secure encrypted channel with the help of SSL. The Puppet slave asks for the Puppet master certificate. After receiving the Puppet master certificate, the master requests for a slave certificate. Once master has signed the slave certificate, the slave requests for configuration or data, and finally the Puppet master sends the configuration to the Puppet slave. And that is how this architecture works. Now let us take a look at a few important Puppet components. Starting out, we have manifests. Now each slave has got its configuration details in Puppet master written in the native Puppet language. These details are written in the language which Puppet can understand, and these are termed as manifests. Now they are composed of Puppet code and their file names using the .pp extension. They are basically like programs of Puppet. For example, you can write a manifest in Puppet Master that creates a file and installs Apache server on all Puppet slaves connected to the Puppet Master. Next, you have a module. Now, Puppet module is a collection of manifests and data such as your facts, files, templates, etc. And they have a specific directory structure. Modules are used for organizing your Puppet code because they allow you to split your code into multiple manifests. Hence, they are also known as self-contained bundles of code and data. Now, the next component of Puppet is a resource. Now, resources are the fundamental unit for a modeling system configuration. Each resource describes some aspect of a system, like a specific service or a package. Next, you have a factor, which gathers your basic information or facts about a Puppet slave, such as hardware details, network settings, operating system type, version, IP addresses, MAC addresses, SSH keys, and more. These facts are then made available in Puppet Master's manifest as variables. Then you have something known as an M collective. It is a framework that allows several jobs to be executed in parallel on multiple slaves. It performs various functions such as interacting with clusters of slaves, whether in small groups or very large deployments, using a broadcast paradigm to distribute requests where all slaves receive all requests at the same time. Requests have filters attached, and only slaves matching the filter can act upon the requests. You can also use simple command line tools to call the remote slaves and write custom reports about your infrastructure using the M collective. Next, and the final component I'm going to talk about is a catalog, which basically describes the desired state of each managed resource on a slave. It is a compilation of all the resources that the Puppet Master applies to a given slave, as well as the relationships between those resources. Now, catalogs are compiled by a Puppet Master from manifests and slave provided data, which includes facts, certificates, and environment if one is provided, as well as an optional external data such as an external slave classifier, exported resources, and functions. The master then serves the compiled catalog to the slave when requested. Now that you know about Puppet, its architecture, and the various components of Puppet, let's understand why should you opt for Puppet or a configuration management tool like Puppet. Now, if you're a poker enthusiast or a card enthusiast, or you've ever played online games, then you must have heard about something called Zynga. It's the world's largest social game developer. Its infrastructure uses tens of thousands of servers in both public cloud and private data centers. Early on, they were using manual processes, including Kickstarters and post installs, to get hundreds of servers online. Now, during the process, they faced a number of different problems. First of all was scalability and consistency. The platform was experiencing phenomenal growth, and its infrastructure needed to keep pace with the industry. Script-based solutions and manual approaches were not really sufficient for these needs. The second problem they were facing was portable infrastructure. Zynga needed a way to leverage a consistent configuration management approach in both their public cloud infrastructure and their own data centers. Now, given the diversity of the various Zynga gaming properties, it was important for the team to be able to quickly match the right configuration to the right machine. Hence, flexibility turned out to be another problem. And finally, infrastructure insights. As the organization matured, it became more important to have an automated method of visualizing the properties of each machine. Now, this company was smart enough to quickly realize the need for an automated process even before they hit rapid scaling, and that's when they got Puppet into the picture. So, with Puppet, the first thing they could expect was speed of recovery. The production operations team could rapidly deploy the right configuration to the right box. If a system got inappropriately reconfigured, Puppet automatically reverted it back to its last stable state and provided the details necessary to manually remediate a system rapidly. The next thing was the speed of deployment. Apart from the speed of recovery, the speed of deployment was also increased manyfold. Puppet provided significant time savings in a way the operations team delivered services for the gaming studios. The next benefit of using Puppet was consistency of servers. Puppet's model driven framework ensured consistent deployments. According to Mark Stockford, who was the vice president of production operations at Zynga, it was evident that they had experienced many ways to save time. The beauty of using Puppet is that, according to him, was that it allowed them to deliver consistent configurations across their servers in a very short period every time. And finally, having a model driven approach using Puppet made it easier for them to share configurations across the organization, which helped enable developers and operations teams to work together and ensure new service delivery was of extremely high quality. Hence, it furthered collaboration. Over a dozen people from the team got trained in Puppet. This knowledge had been disseminated throughout the team and to the operations team within each individual gaming studio. So, speed of recovery, speed of deployment, consistency of servers, and collaboration were the four main benefits of having used Puppet.
So first of all, guys, this is my AWS Management Console. I am going to launch a virtual machine with EC2 using this option. All right, here I'm going to pick my AMI, just filtering it out to free tier only. And if you go down, you'll get an option of Ubuntu Server 18.04, which I'm going to select. And once you've chosen your AMI, in type, I'm going to choose the T2 Micro. And next, move on to configure instance details. All right. So the number of instances we'll be needing is two, one for master and one for agent. So going on next to add storage, add tags, this is unnecessary. You could obviously go ahead and add tags for yourself, but I don't find it significant for this particular demonstration. So I'm going to move on straight to configure security group. So here what I'm going to do is I'm going to add rule, and what we need right now is something that will allow all TCP connections for our agent. So I'm going to go ahead and click on TCP, or you can always go ahead and use a custom TCP for your agent. Okay, so I'm going to do that, and here select from anywhere. All right, and once I'm done with this, I'm going to review and launch. Okay. So basically, I created a new key pair and I launched the instances. Now your instances are going to be launched in a while. Okay. So, all right, what I'm going to do is I'm going to edit the names of both of the instances. I'm going to name one as master, and I'm going to name the other one as slave. All right. So both the instances are running. We'll start with the master first. So now that we have connected to our machines using PuTTY, we're going to start by installing NTP date packages to sync all the date and time on your servers. So first, we're going to sudo apt update. And then we are going to apt install your NTP date. Now what you need to take care of while running these commands, that all of your commands in this installation are run as root. So all of your commands are going to proceed by sudo. All right. Now we have installed our NTP date packages and synced our date, our time on our servers. And all of this is being done in your master machine. Next, we are going to set up hosts file on our machines, and remember to run all these three commands on both of your machines, right? So now on our masters, we're going to edit the host file and add the IP address of the master itself in the hosts file and name it Puppet. So we're going to open nano. All right. On the master, we are going to edit the host file and add the IP address of the master itself, and we are going to name it Puppet. And in the agent, we are again going to go and Nano again, we are going to open the hosts file, add the master, and add the Puppet agent. And then we are going to write out of both. Okay. Next, what we're going to do is we are going to add Puppet repo or repositories on both of your machines. So your Puppet uses port 8140 to communicate through SSL. And we are going to open it through the UFW command. So UFW enable. And then click on Y. All right. And then UFW. And we are going to allow our port number 8140. All right. And remember to do that on all of your machines that we are using, right? So here again, UFW enable and UFW allow 8140. Okay. Now we're going to add the Puppet 6 repository on all of the machines. So we're going to app update first. We're going to get our Puppet 6 package. And we're going to update our system again. And we're going to be doing the same thing on all of the machines that we have, right? All right. Moving on, we are going to install the Puppet server on the master machine. So for that, we are going to apt install an extension Y, your Puppet server. Okay. Now, after this installation, what we're going to do is we're going to change the memory allocation for the Puppet server. Now, the default setting is 2 GB. So we are going to basically set it to half of it or 1/4 of it, which is 1 GB or 500 MB, according to the memory allocated to your particular VM that you have whipped up. All right. So once this is done, what I'm going to do is I'm going to open the default Puppet server file and change one line. All right. So everything is pretty simply explained here. Here we have this one line which says modify this if you'd like to change the memory allocation, enable JMX, etc. So here we have our 2 GB which we are going to change to 1 G. Also remember you can change it to 502 MB as well. Yeah. So it's either half or 1/4. And remember to press I before you try to make any edits to it. Go into insert mode. Remember to be logged in as a root user. So I'm going to click on escape to get out of insert mode. Now you can see I'm not able to insert anything, right? And then I'm just going to exit it. All right. Next, what we have to do is edit our configuration file of Puppet. So we go into Puppet Labs and puppet.conf.
Okay. So here you'll have to add the following lines. Just going to add main cert name equals puppet, server equals puppet, environment will be production, and the run interval. Then I'm going to escape and get out of this. Now that you have edited the configuration file, you're going to need to set up the Puppet server certificate. So for that, you have to go to Puppet Labs, and certificate setup. And this might take some time. And once it's done, you can start and enable your Puppet server. So we're going to do a systemctl start Puppet server, followed by systemctl enable Puppet server. So now that we've started it, we are going to enable it. All right, now you can see something along the lines of executing and your Puppet server is enabled. Now this was all about setting up the Puppet server on the master. So now we are going to install the Puppet agent the same way that we installed the Puppet server by using apt install. And now since I'm using an AWS instance, you can see this takes very little time as opposed to if I were using an actual VM. Yeah. So now I'm going to go into the Puppet configuration file on the agent machine and make a few changes. Think I forgot a space here. All right, we are here. Hit the I so you can make edits in there. Like we had done previously, we have main, we have certification name, we have server, we have environment and runtime. So cert name will be Puppet agent, server will be Puppet, environment will be production, and run interval will be 15 minutes. We're going to hit escape and we're going to quit the VI editor. Next, what we're going to do is we are going to start and enable the Puppet server on the agent machine. So for that, we're going to use this command op/puppetlab/bin/puppet. We're going to call resource service. You can call the master, ensure it's running and enabled. So now you can see that your service, that is Puppet, it's running, it's enabled, and you can see its provider. Now running the Puppet service on the agents will send the certificate for authentication on the master server. So now we're going to move on to signing the certificate, right? We had seen this in our architecture section. For that, we'll first move on to our master machine. Okay, so finally here's an extra bit, which is signing the certificate. This is a small little section which consists of not more than 3 commands. First of all, you're going to list all the certificates left for signing on the master machine. For that, you're going to use the Puppet server CA list command. Then you can choose either to individually sign the certificate or all of them together. So you can either use this command and put the cert name, or you can do a -all. And to verify, you can open the agent and use the test command. And with that, your Puppet installation and setup is complete. And so is this tutorial.
Now this is a very rudimentary tutorial on Puppet, which was meant to answer your questions about why Puppet is so popular in the market, what makes it unique compared to other configuration management tools, along with helping you start out a little bit with Puppet using this guide to install and set up Puppet for you. Now, Puppet as a tool deploys, configures, and manages servers, particularly for the automation of hybrid infrastructure delivery and management. With the help of automation, Puppet enables system administrators to operate faster and easier. It can also be used as a deployment tool as it can deploy software on the system automatically. It implements infrastructure as code, which means that you can test the environment for accurate deployment. It gives amazing platform support, it is scalable, and provides a large number of well-developed, detailed documentation. It's cost-effective, it makes a DevOps professional's work faster, and it is really growing fast. In fact, today many companies have adopted Puppet to manage their infrastructure, such as Google, Red Hat, AT&T, Spotify, and the US Air Force. So hope you would give this tool a try for your individual and organizational needs. I shall leave you with that thought. My name is Upasna. Thank you and have a great day.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!